Hi. Now in this video lecture we will go through the drawbacks of Rutherford model and the development leading to the Bohrs model of atom. Right. Now Rutherford's model, Rutherford's atomic model, we know it's based on the alpha particle scattering experiment. Right. The Bohrs model of atom, Rutherford, before declaring his model of atom, he carried out a famous experiment which we call as Rutherford's scattering experiment, right, or alpha particle scattering experiment. And based on based on his experiment, the observations of his experiment, he declared his model of atom, right. And as per his model of atom, we'll call it as Rutherford atomic model. As per his model of atom, an atom consists of two parts, right. This is what he said. It consists of two parts, right. First was the nucleus, right, where all the mass of the atom is concentrated, right. And he also said that the positively charged particles in the atom are present inside the nucleus, right. And the mass of the nucleus, or the mass of the atom, is due to the positively charged protons and the neutrons, right, neutral neutrons. And there is an extra nuclear part in Rutherford's model, extra nuclear part, that is the part, extra nuclear part is the part around the nucleus, right, outside the nucleus, right. So it consists of two parts, nucleus and extra nuclear part. And about the nucleus, if you remember, we have done this alpha particle scattering in the previous lecture. When the alpha particles, when they collided with the positively charged part of the atom, some of the very few alpha particles, 1 in 20,000, they bounced back, right. When they collided, when they did head-on collision with this positively charged part of the atom, they just bounced back, right. They bounced back into the source. So using this observation, what he concluded, that this atom, right, this positively charged part of the atom is massive, right, is massive, and it's positively charged because the alpha particles retraced back or bounced back, right. So this was one of the important contribution of Rutherford model, that he discovered the nucleus, and it is nucleus that contains protons and neutrons, right. This is the most important contribution of Rutherford model, which continued in the future Bohr model as well, right. And make sure you understand this, that this positively charged nucleus is massive and is positively charged because of the protons, because of the positively charged protons, and is massive due to protons plus neutrons, right. This was as per Rutherford's model, right. Now he also said that there is an extra nuclear part. If this is the nucleus, right, there is an extra nuclear part which is around the nucleus, right, like this extra nuclear part. In this extra nuclear part you have electrons that are revolving, right. In this extra nuclear part you have electrons revolving at a very high speed, right. He just said that electrons revolving at a high speed, right. So Rutherford model, if you look at this is the nucleus, right, this is the nucleus, and these are electrons, right. So the Rutherford model was compared to the solar system, right. Nucleus is in the position of sun, and these electrons are like orbits, are in the position of orbits that are revolving in their specific orbits in the solar system. If you name solar system, right, this is the sun, right, and you have different planets moving like this, right, around the sun. This is your sun, and these are your planets, right? And this is sun, which is at the center. Similarly, nucleus is at the center and electrons are revolving in different orbits at a high speed, right? So due to this comparison, these electrons are known as planetary electrons, because these are compared to planets, so these are planetary electrons, right? So here Rutherford model could discover the nucleus based on his alpha particle scattering experiment, and he said that all the mass is concentrated inside the nucleus, right? And mass consists of protons plus neutrons. In the nucleus we have protons plus neutrons, right? And extranuclear part contains fast moving electrons revolving at high speed in different orbits. Right, these were two major points, right, of Rutherford atomic model. But if you just look more deeper into the comparison of Rutherford atomic model with the solar system, we'll notice some points of differences. That here the electrons that are revolving around the nucleus are negatively charged particles, right? And these are very small microscopic particles, right? So in atomic model, so we'll just write that the electrons are microscopic charged particles revolving around the nucleus, right? Revolving around the nucleus. Whereas if you look at the solar system model, these are planets, right? Planets are revolving, and these planets are big bodies, right? And these are not charged, right? So these are revolving electrons, and revolving planets this was first difference, this was second difference. Revolving planets are massive bodies, massive or big bodies that does not carry any charge, right? So since these are microscopic small bodies, electrons we know are microscopic particles which cannot be even seen under high resolving microscope, right? So if you remember from physics, we have Newton's laws of gravitation, right? So to these microscopic particles, right, we cannot apply Newton's laws of motion, right? So laws of motions are not applicable to these revolving electrons, right? And second is, revolving planets are massive, big bodies that do not carry any charge, right? Like electrons are negatively charged that are revolving around the nucleus. These bodies, these planetary bodies, these planets does not carry any charge, right? They are neutral, right? So this is the major point of difference which we would be using in its drawbacks, right? What will lead to the drawback of Rutherford model. So just make sure that you understand these 2 points, right? That these are microscopic particles, you cannot apply laws of motion, and these are charged particles, right, that are revolving around the nucleus, right? And these planets do not carry any charge, they are neutral, right? Now one important thing is that Rutherford atomic model, it just said that electrons are revolving around the nucleus at a very high speed, right? It did not talk much about how these electrons are distributed around the nucleus, because today now we know, you remember if in your in your previous classes when you draw orbital diagrams, you draw electrons in various orbits, right? And we say that as you move away from the nucleus, the energy of the orbits keeps on increasing, right? So he did not talk about these orbits, their energies, right? He did not basically detailed how electrons are distributed in various orbits, right, around the nucleus, right? So this was one of the drawback of Rutherford model, where he could not explain the distribution of electrons around the nucleus, right? So this was the drawback. Drawbacks are, first was how electrons are distributed around the nucleus, right? This he could not explain, right? Now, to look into the second thing, we need to look at the second drawback. It's regarding the motion of electrons, right, around the nucleus, right? But before we go ahead, if you remember in the Rutherford atomic model, what he explained regarding the stability of atom. Regarding the stability of atom, Rutherford said that these electrons, because these electrons are negatively charged and this nucleus is positively charged, so ideally this electron should be attracted by the positively charged nucleus and should fall into the nucleus, thus destroying the atom, right? But this does not happen as we know today. So what Rutherford said, that when these electrons are moving, right, since they are revolving around the nucleus, so they are acted upon by an equal and opposite centrifugal force, right? This is the centrifugal force that act outwards. There is one force that is acting inward, right? This force which is acting inward due to attraction between the electrons and the positively charged nucleus, and there is an equal and opposite force due to the revolution of this electron around the nucleus, which is called as centrifugal force. So this centrifugal force is balancing this inward force, due to which this electrons does not fall into the nucleus, right? But since this is a charged body, this is a charged particle, so as per Maxwell, as per the Maxwell's theory, what Maxwell says, that when a charged particle is revolving, right, when a charged particle is revolving, it will continuously lose energy, right, in the form of electromagnetic radiation, right? So when it will lose energy, if this electron is revolving in this outermost orbit, right, so due to its revolution, if this electron loses energy, it will keep falling into inner orbits, right? It will first come to this orbit, then it will come to this orbit, then it will come to more inner orbit, finally it will fall into the nucleus, right, thus destroying the nucleus. But today we know that atom is stable, right? So the stability of atom could not be explained by Rutherford, because as per Maxwell, this should not be applicable, because Newtonian laws of motion is not applicable to revolving electrons, and the charge, as this is a charged particle, it's moving under this positively charged, under the force of this positively charged nucleus. So ideally this negatively charged electrons should keep losing energy and should keep falling into the inner orbits and should finally spiral into this nucleus, should fall into this nucleus, thus destroying the atom. But we know this does not happen. We know that atom is stable, right? So this is contradiction, right, to the stability of atom, and Rutherford could not explain this, right? So as per Maxwell's theory, A revolving electron should continuously lose energy and fall into inner orbits, and finally should fall into the nucleus, thus destroying the atom, right? And it is observed that for an electron to fall into the nucleus or to spiral into the nucleus, it takes 10 to the power of minus 8 seconds. It takes 10 to the power of minus 8 second, right, for an electron to fall into the nucleus, right? But today we know that this does not happen, right? So this was contradiction in the Rutherford model, right, that states that electrons are revolving around the nucleus, right? If electrons are revolving around the nucleus in different orbits, right, because this is what said by Rutherford, that electrons are revolving at a high speed in different orbits, right? But since we know that electrons are negatively charged, so as per Clerk-Maxwell's theory, this electron should continuously lose energy and keep falling into the inner orbits, and finally should fall into the nucleus, thus destroying the atom. But we know this does not happen, so this contradicts to the stability of atom, and it takes around 10 to the power of minus 8 seconds for an electron to fall into the nucleus, right? Now this was the major drawback of Rutherford model, right, wherein he compared his model of atom with the solar system, right? And these are two main differences between the solar system and the nuclear model, right? So these two are important points, right? So remember the Clerk-Maxwell's electromagnetic theory that says that it should fall into the nucleus because a charged revolving body will keep continuously losing energy, right, and will keep falling into the inner orbits. Why we said inner orbits? Because we know that if this is the nucleus, right, and if you keep going far from the nucleus, the energies E1, E2, E3, if these E1, E2, E3, E4 represents the energy of orbits, then E1 is at highest energy, right? E3, the energy of E3 is less than E4, and finally the energy of E1 is less than E2, E3, E4, right? So electrons should keep falling into inner orbits, right, and will fall into nucleus in this much of time, right? So this was the contradiction. It could not explain the stability of atom, right? First was how electrons are distributed around the nucleus, right? It could not explain this, right? And the second was it could not explain the stability of atom, right? Because based on his explanation, the electron should fall into the nucleus, which is contradictory to what we say that atom is stable, right? So these are two main drawbacks of Rutherford atomic model, that this model of atom could not explain how electrons are distributed around the nucleus, because Rutherford just said that electrons are revolving at a very high speed, right, around the nucleus, but he did not talk much about the energies of electrons or the energies of orbits, right, which later was improved by Niels Bohr, right? Because he talked about how electrons are distributed in various orbits around the nucleus, right? And there is one more drawback, that Rutherford model could not explain the line spectrum of elements. We know that elements, like sodium, you have sodium element, so, and hydrogen, all these produce line spectrum, right? So it could not explain the line spectrum of elements, right? Line spectrum we'll do in next video lecture. You'll understand that in another lecture. And it could not explain the line spectrum. Right? These are three major drawbacks of Rutherford models. Right? Rutherford model. So about line spectrum was explained when Bohr's model came, when he explained how electrons are distributed in various orbits around the nucleus, right? When he explained that, then this spectrum of atomic elements was made clear, how spectrum of atomic elements are produced, right? Because he used the concept of Niels Bohr. What he did, he used the concept of stationary orbits, that all these orbits have stationary energy, they have constant energy, their energy is fixed, the energy of these orbits is fixed, and electrons are revolving around these stationary orbits. Stationary with respect to these orbits are stationary with respect to energy, not with respect to electrons. Electrons are revolving in these stationary orbits, right? So he used the concept of stationary orbits, and he said that electronic transition takes place when an energy is lost or gained by an atom. If you supply energy to an atom, the electrons will gain energy and will move to higher orbits of higher energy, right? And when these electrons that are in higher orbits will return back to their ground state, right, to the lower orbits, they emit radiation or energy, right? And it is due to this emission of energy that you see that these line spectrum and other things are explained, right? So what lead to the development of Bohr's model? Bohr model is an improved form of Rutherford model, right? And from Rutherford model, now we are clear that there is a nucleus which is positively charged, and all the mass of the atom is concentrated in this small massive body which is called as nucleus. This is clear from the Rutherford model, and this is the contribution of Rutherford model, right? So this is the contribution of Rutherford model. But when we talk about this extra nuclear part, this was later improved and explained by Niels Bohr, right? Scientist Niels Bohr, where what Niels Bohr did, I just introduce you to this, because this we would be doing Bohr model of atom, we will be doing in detail in next video lectures. Niels Bohr, what he did, he used the concept of stationary orbits, right, in which electrons are moving, right? And then he talked about electronic transitions, right? He talked about electronic transitions when energy is supplied to an atom, right? So when energy is supplied to these electrons will move to higher orbits. This is what electronic transition is, right? So Bohr used the concept of electronic transition, from lower orbits to higher orbits, then from higher orbits back to lower orbits. When electrons will move from higher orbits back to lower orbits, they will emit radiations, right, or energy. So the first thing that was used by Bohr was the concept of stationary orbits in which electrons are moving. The second was electronic transition, right? These were the two major things that was used by that was used by Niels Bohr, and he explained his atomic model based on Planck's quantum theory. Planck's quantum theory, and as per Planck's quantum theory, the energy is emitted, right, not continuously in the form of waves, but discontinuously in the form of packets, and those packets of energy are known as quantum, right? So this is important. Bohr used Planck's quantum theory to explain his model of atom, or he used Planck's quantum theory in his model of atom, right? In which, and based on Planck's quantum theory, what it says that energy is emitted in the form of packets known as quantum, right? We would be explaining this in detail in coming video lectures when we will talk about Bohr's atomic model, right? So important thing in this video lecture is Rutherford atomic model, right? has explained that atom consists of two parts, nucleus and extranuclear part. Nucleus, right, based on his experiment, alpha particle scattering experiment, said that nucleus is a massive body and the entire mass of the atom is concentrated inside the nucleus, right? This is the first part. Then there is a second part, and Rutherford said that electrons are revolving around the nucleus in different orbits, and they are moving at high speed in different orbits, electrons. And he did not talk much about the distribution of electrons in different orbits, right, around the nucleus. His model of atom was compared to the solar system, where sun is at the center, compared to the nucleus, and planets are revolving in their definite orbits, right, in the fixed orbits, right, like electrons are moving in different orbits around the nucleus, right? But we know that electrons are charged, right, and planets are not charged, right? And electrons are microscopic particles to which the laws of gravitation or the Newton laws of motion could not be applied, right? And since now, coming to the drawbacks, it did not talk much about how electrons are distributed in various orbits. It just said that electrons are moving in different orbits. It did not talk much about how electrons are distributed around the nucleus. This was the first drawback. The second was, it did not explain the stability of atom, because he said that electrons are charged and they are revolving at a high speed, right? But as per Clerk-Maxwell, if a charged body is revolving, then the charged body, if revolving, will continuously emit radiation or energy, and will lose energy and will keep moving into lower orbits, and will finally fall into the nucleus in this much of time, 10 to the power of -8 seconds, thus destroying the atom. This is contrary to what we say that an atom is stable, right? So this was not explained. The stability of atom was not explained based on Rutherford model. The third was, it could not explain the line spectrum, right? The line spectrum of elements like sodium, hydrogen could not be explained by Rutherford model, right? Now, coming to the improvements in the Rutherford model, the improvements in the Rutherford model was done by Niels Bohr, right, who used the concept of stationary orbits, in which electrons are moving. We missed electrons here. Stationary orbits, these are stationary orbits, right, as per Niels Bohr, in which electrons are moving, right? This was the first point, and he used the concept of electronic transitions, right, which could explain the line spectrum of atomic elements, right? He used the concept of electronic transition, that is, when we give energy, these electrons will move to higher orbits, right, which is excited state. When these electrons move to higher orbits, we call the electron atom is in excited state, right? So, and when electrons will return from their excited state back to their ground state, they will emit radiation, which will explain the line spectrum, right? So, and Niels Bohr used Planck's quantum theory to explain his concept of atomic model, right, which says that, so we'll do this in